What if I told you that in the age of AI, algorithms, and architectural wonders that reach into the clouds, we still cannot replicate something built over 4,500 years ago? In a world where skyscrapers scrape the sky with steel bones and glass skin, where satellites orbit the Earth at 17,000 miles per hour, where digital design tools can generate entire smart cities with the precision of a god, there lies a stone giant in the desert, silently mocking us with its permanence. The Great Pyramid of Giza. A 6 million-ton enigma, rising from the sands without machines, without motors, without blueprints, just stone, just sweat, just sheer, human will. It's aligned nearly perfectly to true north, more accurately than most buildings today. Each of its 2.3 million stones was placed with such precision that you can't fit a razor blade between many of them. Some of these blocks weigh up to 80 tons, the size of a locomotive. And yet, no steel tools, no concrete mixers, no cranes. So here's the question: why can't we rebuild the pyramids, even with everything we have today? What exactly did the ancients know that we don't? Because if they did this with bare hands and copper tools, then maybe the mystery isn't about their limitations. Maybe it's about ours. To understand the mystery of the Great Pyramid, we have to go back, far back, to a time before Rome, before Greece, before the Bible was written. The year is around 2560 BCE. In the heart of the ancient Egyptian Old Kingdom, a young and ambitious pharaoh named Khufu, also known by his Greek name, Cheops, begins planning a monument that will become the centerpiece of his legacy. He doesn't just want a tomb. He wants immortality carved into stone. A staircase to the gods. A structure that defies time itself. This is an Egypt unlike the one we imagine today. Not just pyramids and mummies, but a vast, sophisticated civilization thriving along the life-giving waters of the Nile. Its engineers understood geometry. Its astronomers tracked stars and seasons. Its workers were not slaves, as once believed, but skilled laborers, well-fed, well-housed, and driven by a deep spiritual and cultural purpose. Khufu's vision would rise on the Giza Plateau, a desert ridge west of modern-day Cairo. There, his architects would begin assembling the most extraordinary structure humanity had ever attempted, the Great Pyramid. Over the next 2 decades, they would move more than 6 million tons of limestone and granite into place, one block at a time, to form a structure standing 481 feet high, the tallest man-made object on Earth for nearly 4,000 years. But how exactly this was done remains one of history's most persistent enigmas. There are no surviving blueprints. No detailed records. Just scattered tomb paintings, fragments of tools, and the structure itself, standing defiant in the face of time. And while the pyramid may have been completed over 4,500 years ago, our obsession with it has only grown. From Herodotus to Napoleon, from early explorers to modern drone scanners, generation after generation has looked up at this stone mountain and asked the same question: how? And maybe more importantly, why? Why build something so colossal, so mathematically precise, so perfectly aligned with the cardinal directions, with no practical purpose beyond housing a dead king? Was it pure ego? Was it religion? Or was it something else entirely? What's remarkable is that while many ancient wonders have crumbled into dust, the Great Pyramid remains, battered but unbroken. It has survived earthquakes, invasions, erosion, and centuries of looting. It has outlived empires. It has become a symbol not just of Egypt, but of human possibility. And yet, for all our modern marvels, for all our technology, our machines, our satellites, and software, we still can't fully explain how it was made. That's why the Great Pyramid still fascinates scientists, engineers, and historians today. Because it's more than just a monument, it's a riddle in stone. One that asks, what was lost over the millennia? What ancient knowledge did the builders possess? And why do their achievements still feel out of reach, even in the 21st century? The deeper we look into the past, the more we're forced to confront a humbling possibility, that ancient civilizations weren't just early versions of us. They may have known things we've long forgotten. Before we even get into how the Great Pyramid may have been built, we have to understand the scale of what we're talking about, because only then can you appreciate the magnitude of the mystery. The Great Pyramid of Giza originally stood 146.6 meters tall, the equivalent of a modern 48-story skyscraper. Its base is over 750 feet on each side, and it's estimated to contain 2.3 million blocks of stone, ranging in weight from 2 tons to an astonishing 80 tons. All of this placed with extraordinary precision, with gaps between the stones so thin you can't fit a razor blade. Now consider this: Egyptologists believe the entire pyramid was built in about 20 to 23 years. That would mean one stone was quarried, shaped, transported, and placed approximately every 2 to 3 minutes, non-stop, day and night, for over 2 decades. And they did all of this without steel, without diesel engines, without cranes. Just copper tools, ropes, sleds, and human labor. Even today, engineers balk at the logistics. Modern machinery like cranes, trucks, and precision cutting tools could help, but not without enormous effort, resources, and coordination. And yet, the ancient Egyptians, without any of that, somehow achieved something so flawless it continues to baffle the world's top architects. But what's even more mind-blowing than the mass of the pyramid is its precision. The structure is aligned to true north with an error of only 0.067 degrees, more precise than the Royal Observatory in Greenwich. The base of the pyramid is almost perfectly level, differing by less than a few centimeters across the entire 13-acre platform. And the sides of the base are nearly exact in length, differing by mere inches. These aren't accidents. They're engineering on a scale we can't easily replicate. As Mark Lehner, one of the world's leading Egyptologists, once said, "It's not just the scale, it's the math, the astronomy, the logistics. Everything about this structure screams impossible, unless we're missing something." Now let's talk about the how. How did ancient Egyptians, with no wheels, no steel tools, and no industrial machinery, lift and place stones that weighed up to 80 tons? The most widely accepted theory, and the one still taught in textbooks, is that they used ramps. Long, straight ramps built from mud brick and limestone chippings that stretched away from the base of the pyramid at a manageable angle. Laborers would then drag the stones up these ramps using wooden sledges, ropes, and pure manpower. But this explanation has a serious problem. If the pyramid is over 140 meters tall, the ramp would need to be at least a mile long to maintain a slope gentle enough for dragging multi-ton stones. Building such a ramp would have required more material than the pyramid itself, and left behind massive archaeological remains. Yet, no ramp of this scale has ever been found. That's why some archaeologists proposed a different theory: spiral ramps that wrapped around the pyramid as it rose. Others, like French architect Jean-Pierre Houdin, suggest the ramps were internal, spiraling up inside the pyramid's walls. In CGI simulations, the idea makes elegant sense, but again, the evidence is mostly theoretical. We haven't discovered internal tunnels that match this claim, at least, not yet. Then there are alternative techniques, each more fascinating than the last. One of the most intriguing comes from a seemingly minor detail in an ancient Egyptian wall painting. In it, laborers are shown pulling a giant statue on a sledge, but at the front of the sledge, a man is pouring water onto the sand. For centuries, this detail was overlooked as ceremonial. But in 2014, researchers at the University of Amsterdam discovered something remarkable: pouring water on sand reduces friction by nearly 50%. It allows the sled to glide instead of drag. Modern experiments confirmed it. Wet sand behaves like a solid but slippery surface, perfect for transporting heavy objects. Then there's the theory of sand liquefaction, where sand is vibrated or moistened to temporarily act like a fluid. Some engineers have experimented with this idea, showing it could significantly reduce resistance when pulling sleds. While there's no proof the Egyptians used this method intentionally, their deep understanding of the natural world, from astronomy to hydraulics, suggests it wouldn't have been beyond them. But perhaps the biggest mystery isn't what tools they used, it's what tools they didn't use. Take granite, for example, one of the hardest stones on Earth. The inner chambers of the Great Pyramid, including the King's Chamber, are lined with massive granite blocks. Yet the only metal tools the Egyptians had were copper chisels, which are too soft to cut granite. In modern experiments, archaeologists have tried replicating these cuts. In the 1995 Nova Pyramid project, teams tried using traditional copper tools. The copper dulled within minutes. Eventually, they had to switch to modern equipment just to make progress. So what were the ancient Egyptians using? Were they pounding the stone instead of cutting it? Did they use abrasives, like sand mixed with water? Or did they have tools we simply haven't discovered? That's the heart of this segment. It's not just about what methods we think they used, it's about how little we actually know. There is no single conclusive method that explains how the pyramids were built. Every theory has gaps. Every tool raises more questions. We are standing in the shadow of a 6 million ton mystery, one that forces us to confront the limits of what we assume about the ancient world. Because maybe the question isn't, why don't we know how they did it? Maybe the question is, how could they have known all this, and we forgot?